In other cases, just a bit better extension strategy for general purpose contracts so that you can spread out the extension fees among users more evenly by limiting max extension. And the way we achieve this is described in the CAP. We provide a new interface for the TL extension function, or rather two functions, one for the contract data, another is for contract instance in code. And instead of the old threshold parameters that defined TL extension, we define just the range of min extension and max extensions that tells that extension will be only performed if it is at least min extension, and then it will be clamped by max extension. So you can set up more complex TTL management strategies. I don't think there is a need to go into math more deeply. Basically, there is some edge case handling, but the gist of it is really that besides limiting the minimum extension necessary to actually extend TTL, you can now cap the max extension. So please take a look at the CAP for more details, and if there are any questions regarding this CAP right now, please feel free to ask. Someone said, I guess, the only kind of tricky part. Okay, so the question is, for example, current TTL is at ledger 10, extend to 20, min 5, max 8, extend would work with current. Okay, so it is important to distinguish between TTL and live until ledger. TTL is basically how long will entry live from this moment. So for example, we are on ledger n, and live until ledger is like n plus 1,000. That means that TTL is 1,000 ledgers, because the entry will live for 1,000 ledgers from now. So let's say your current TTL, not ledger, is 1,000 ledgers. And then you can say, I want to extend the TTL to be 10,000 ledgers, but only allow extending by, let's say, 500 ledgers at a time. So for example, if you're on 1,000 ledgers now, your target is 10,000. Every user that calls it will extend the entry just by 500 ledgers. And that's limiting the fees every individual caller would pay. And on the other hand, again, the same scenario, you want your TTL to be 10,000, but it's already 9,999. The extension will be just one additional ledger, and if your main extension is, for example, 100 ledgers, and if you want to pass the check, and TTL extension will not happen at all, which is basically similar to what threshold does, but just is a the math is a bit different, but the end result is exactly the same, I believe. I think it is a topic that is easier to digest, like use a piece of paper than trying to explain it, but has all the equations, so you can plug in some numbers and see what comes out of it. Yeah, so the other consideration I wanted to add is that for temporary entries, max extension will work in the same way, which may or may not be a bit of a foot gun, because if you miss the extension of a temporary entry, it will be gone forever, and this may not be desirable for a lot of use cases of temporary entries. So generally speaking, this min and max extension parameters, so the threshold parameter in the existing functions, is really more for the fee management, for the persistent entries, and for the temp entries. You generally want the extension to always happen in precise fashion, or else you're risking to just lose your temporary entry because extension hasn't happened. And yeah, protocol allows that, but probably at this decay level, we'll try to make sure this the default is reasonable, and it is hard to do something weird for this extension because you misconfigured your min and max extension. Okay. Wait for like a few more moments if no one is typing. Voice is breaking. Well, I apologize for that, but I'm not sure if I can do anything. Okay. Yeah, it may be Discord acting up on people. Yeah, sure. Well, what can I do about it? Right. If you have any further questions or suggestions regarding this CAP, the discussion has been linked above, so please feel free to comment asynchronously. And with that, let's proceed to CAP-79. Let me link it. Okay, we have linked it, thanks. This one is a simple CAP as well, and it just adds host functions for the MuxedAddress string key conversions, and it basically closes a bit of feature gap or an oversight we've introduced in Protocol 23. In Protocol 23, we've introduced a new type of address, MuxedAddress, which allows users to specify an additional subject to 64-bit pill. Yeah. I forgot that. Sorry, to 64 bits. Doesn't really matter, but basically, it allows users to specify an additional memo together with their public key. And then this memo can be consumed by the exchanges to distinguish between multiple users that have the same address on chain, so that we can have a custodial account that has multiple users but only a single ledger entry holding the balance on chain. Yeah. So okay. Try to actually disable noise suppression. I know that it introduced some artifacts before. Hope it's better now. So yeah, anyways, coming back to the CAP, MuxedAddresses have been added in Protocol 23. You can pass them in as contract arguments, but what has been missed is the strkey format conversions that exist for regular addresses, and there are use cases for strkeys, mainly breach protocols, so protocols that generally do anything cross-chain, and strkey is common format to use for messaging. Like if you need to specify store destination from the other chain, strkey is a preferred format, and not being able to handle strkey for max addresses kind of limits these protocols. I guess the CAP is very straightforward. It just does the conversions. The only thing about it is that, well, potentially, not potentially, but we have already implemented this functionality in the SDK. So there is potentially an argument of, well, why do we even have it in host? And I think in this case, It is mostly for the sake of the full feature set. Like we already have the strkey conversions, which was possible to get away without the host functions before. And of course, doing things on the host side is just cheaper and with more future-proof, hopefully, because the implementation can be, for example, fixed without updating any contract in case there are some subtle issues, which we hope won't be the case. So yeah, that's the CAP, and I guess in this case, yeah, it's just cheap enough to implement to kind of have it product have consistent host function coverage for all the address kind instead of this weird feature gaps that we have right now. Yeah, exactly, Matthias. Feature part, I think, is the main driver here. Okay. Again, I will not. Okay. Key to MuxedAddress. No, the CAP. Okay, maybe I should have answered the CAP specification. The CAP returns either address object for the regular strkeys, or well, yeah, I guess it's a semantics question. What do we even call address? Because we have these two different object types, like address object and MuxedAddress object, and the function can return either one of them. So I guess kind of very philosophical question. It should be called to MuxedAddress or just to address. Yeah, I'll give it a thought probably, but yeah, it doesn't seem very important in the end, I think. I guess my intention here is that v2 would be used going forward for all the use cases, so that you can just safely stop using v1 in the SDK, and there won't be any semantic weirdness. All right, we'll spend a few more moments before typing. Address. That's a good question. Yeah, I think if address is using the old ones, and you can name this more specifically for max addresses. Because, like, yeah, you could use a new function, but then you will need to distinguish between different object types and fail, and that's unnecessary work. Yeah, I agree that old function is still useful for the case of like normal address conversions. Actually, you kind of do care if it is an M or G address, because some addresses are like a bit Fudgani. We try to limit the scope of where you can use them. For example, you cannot require auth from M address. You need to convert it to a normal address first. And yeah, not every contract can deal with M address correctly, which is why it's completely its own thing. So basically, MuxedAddress is a superset of address. So if you can deal with MuxedAddress, you can deal with address, but not vice versa. Yeah, I think that's a good suggestion. Yeah, I think after reconsidering this, yeah, I agree that to MuxedAddress and MuxedAddress to strkey sounds more in line with how we use them. Thank you for the suggestion. I will update the CAP accordingly. Okay. Wait a bit more. Right, as usual, any questions or comments can be left on the discussion thread, and let us move to CAP-77, right, Boston. And this CAP is much less straightforward than the previous two, and to give a bit of background of why this came up, as some of all of you may know, we had an incident in protocol 23 caused by data corruption bug, and the initial response when the incident has been discovered was to make it so the corrupted data cannot be accessed to prevent further corruption before we understand it better. And that was especially relevant for the entries that have been corrupted but not yet restored. So, like for these entries, we definitely have prevented further breakages and corruption. And the way this has been achieved was via an emergency release of Tower Core that basically just hard-coded some hard-coded the affected contract data keys and rejected any transactions that accessed any of these bad keys in the footprint. Yes, and yeah, I will talk about this. Yes, and this has been achieved without any protocol changes, right? Yeah, these CAP validators will have to agree. I'm just talking about like to provide some background. Like what validators can do today without any protocol changes or anything is that they can just exclude transactions from the mempool. They can do this for whatever arbitrary malicious and non-malicious reasons, but it's an important thing to understand when thinking about this CAP because it's doing something like very uniquely different from what validators can do today. So yeah, for this corruption issue, custom core build would reject the transactions that try to access bad keys at the mempool level, and corruption could only be prevented at the moment when every tier 1 validator has updated to this new core build such that there is no way that a transaction would end up in a transaction set that accesses corrupted data. And it is a very fragile and time-consuming procedure, right? Because first, a new release has to be pushed, and second, you need like 100% consensus on this, so to speak, like consensus at the level of build, and it is not providing any guarantees soon because there can roll back the build for whatever intentional or unintentional reason. Which motivated the CAP that would allow doing something like this at the protocol level. And the benefit of this, at least conceptually, doing this at protocol level is well, an explicit consensus of validators is required, which is both good from the transparency standpoint, right? Because it is possible to observe what validators have voted for. But also from the emergency response standpoint, we actually need lower percentage than 100 to agree on applying a network upgrade. So even if not every validator, but just let's say 5 out of 7, let's say current network config right now, arm the upgrades that would freeze these ledger keys, then the upgrade will go through, and Also, it is not easily reversible without answer votes, so there is no concern that, oh, what if someone changes their build and whatnot. Obviously, this is the case. Like this scenario is something that we'd like to avoid in the future. Which is, I guess, one of the arguments maybe against this CAP is, well, we probably don't want to have any similar data corruption issues in the future, but of course, it is never possible to say that the system is 100% formally valid and will never ever result in any bugs. So that's a bit of trade-off between like making protocol more complicated because of chains if data gets corrupted again for whatever reason, and freezing the keys would be the right remediation for this. And another potential motivation for this would be if there is like known hack, a vulnerability that affects some contracts or users, for example. There is a theoretical possibility for freezing the balances, but I think this case is much less clear if it is relevant or not, because if you are talking about like some high-profile hacks, it might be really tricky to chase right entries, unlike the cases of bugs where they're likely not being exploited actively, and the impact is more or less limited to some set of entries affected somehow. But it's still a consideration. Okay, let me read the question from chat. Yes. So now, in terms of the actual ways the CAP works, like it covers three kinds of entries. Oh, I guess, yeah, on a high level, just two kinds: store-bound entries and non-store-bound entries. And for non-store-bound entries, we're only considering account and trust-bound entries because this seems to be like if we bother implementing this logic for classic entries, these two seem like the most obvious candidates. Everything else on classic does not actually hold value usually, and the risk of like even if corruption happens, there the consequences are probably pretty tame, and it's more of a complex trade-off. And store-bound only entries, of course, can only be accessed from store-bound, which makes the freeze process much easier. And now to answer this question, yes, if network votes to freeze contract code key, for example, then any transaction that accesses this contract will be rejected. It will not even fail till not even be included into ledger. So I don't know, for example, if a contract gets corrupted for whatever reason and skips authorization check somehow, right? Freezing the contract is actually a good remediation because the users will not be able to interact with a vulnerable contract. Okay. Yeah, basically, what the use cases that will die are listed in the CAP. But the idea is that any interaction, either read-only or write interaction with the entry is prohibited, with like one small exception listed there again for the sake of simplicity. But the idea is that the entry cannot be accessed. It's not only that you cannot, for example, modify balance, it's also that you cannot even read it. Right? If you try to read this balance, you will fail as well, because if balance is corrupted, for example, then you may arrive at bad results, which happened, for example, with Protocol 23 corruption bug, where liquidity pool got incorrect balances. Thus, actually, don't recall if the data inside the pool was corrupted further, but there is definitely a risk of this happening. Like if you have any mass based on just reading the corrupted entry, this mass may go wrong, and then you may end up in bad state in an unrelated contract. So yeah, let me continue with this spec. That may answer some more questions. So yeah, basically, as I mentioned, the intention is to not include the transactions into ledger at all. If we get into dealing with account and trustworthy entries, that's unfortunately not always possible because unlike Soroban, there are no footprints for classic operations, and it is not always possible to know if a frozen entry is even being accessed, which is why a fraction of transactions would fail at applied time, and there's also some separate logic for handling DEX described in the CAP that I will talk about in more detail later. But yeah, the intent is really just to prevent the interactions with the entries, and unfortunately the way of doing this is kind of complicated because of, like, if we include classic. If we don't include classics, then it is as simple as filtering based on Soroban footprint. So let me talk a bit in more detail about the semantics. First is the upgrade process as well. It needs to be customized a little bit compared to the normal network upgrades as well, because the maximum size of the network upgrade is limited by the contract data size, and it may be a limiting factor if we need to increase a large number of keys, which is why the CAP proposes structure where delta of the changes in the frozen entries is voted for, so that the total amount of frozen keys can exceed the contract data entry size and can be updated incrementally. That's a bit of an extension on the current upgrade process, which is rather straightforward, but again, it's like a bit of additional complexity of this CAP. And now to the fun part of how actually this would be implemented at the protocol level. So as I mentioned, for Soroban transactions, things are very simple. If we see a frozen key in the footprint, we reject the transaction, and that's it. We don't need to do anything else. We can also, like, if an account is frozen and it's a source account of a transaction or operation, again, we just reject the transaction. That's simple as well. Then the CAP lists operations where it is easy to say what is a source, trust line, destination account, or trust line by just looking at the operation, which is a good chunk of the operation. So basically, again, if we enforce that a frozen account or trust line is accessed, reject the transaction, and everything is good. Now, to the non-trivial operations. First, claimable balance operations. We claim claimable balance and liquidity pool, deposit, and withdrawals are using opaque identifiers, and without doing some logic, it's not possible to tell what the destination is unless we do some additional type of indexing, which I'm not sure if you want to do. But the suggestion here is just to fail at the applied time if frozen key is being accessed after we have actually determined what are the actual trust lines participating in the operation. And I believe for claimable balances, it's even more tricky because a balance can have multiple. Please never mind that. I said something incorrect. Anyway, this is like a bit ugly, but still straightforward. What is ugly and kind of complicated is DEX operations. So again, if you wanted to support freezing trust lines and accounts, then we need to care about DEX, classic storage DEX, and of course it is not possible to tell beforehand if a frozen balance is being affected by a DEX operation. It will only be known at the applied time, and then at the applied time we could also just fail if we encounter an offer that would result in modifying that balance, frozen balance, but that would effectively freeze a whole asset pair for trading, which is a bit of an unexpected impact for the change week. We want to be pretty surgical about this, like we want to prevent operations that depend on corrupted entries, but we don't really want to disrupt network activity more than necessary beyond that. And freezing whole trading pair on DEX may be problematic. Of course, chances of that happening are not very high, but still we want to prevent this in the protocol. So the proposal in the CAP is, instead of freezing the pair, is to emulate crossing this offer without modifying any balances and just remove it, which is not great. We remove an offer, but it kind of gets around the issue of freezing the whole trading pair. And of course, we could add some more complex logic to just skip it, but we would need to skip it every time we encounter it. And yeah, it would require some pretty invasive changes to classic DEX for a very limited use case that we don't even know if it happens. So the proposed solution is basically a trade-off between complexity and usability of not freezing the whole trading pair. Kind of agree it's not pretty, but it's the best we could come up with that seems like relatively non-intrusive. And the last but not least exception to all this mess is, well, if an account is frozen, what happens if someone removes an entry sponsored by this account? And again, it would kind of be weird to fail everyone that has this indirect sponsorship dependency on a frozen account, which is why the suggestion in the CAP is to allow modification of non-sponsoring field, which is a bit of a leak of the free semantics, but it seems acceptable as we are not really touching the balance or anything like that. It's just sponsorship field, and it's really unlikely to be corrupted. And even if it is corrupted, we can just yeah, it should be relatively easy to fix if necessary by protocol upgrade. So it seems like again it is a trade-off between like complexity, because tracing the sponsorships to free frozen entries is much more complex and probably needs to happen at runtime for every operation, which seems like a lot of overhead. So this is basically a small compromise between complexity and limiting impact to only what is hopefully relevant. Contracts do not So I see a question from John. What other challenges exist in having contracts call the DEX? Contracts cannot call the classic DEX at the moment, and I'm not sure if they will ever be able to, precisely because of the reasons for why we have all this nice logic here. It is not possible to know beforehand what is the data that will be modified by any operation involving DEX, which is going against this Sorban data model where we define everything that is going to be accessed in the footprint. So yeah, contracts cannot call DEX, but for the purpose, like if you wanted to freeze accounts and trust lines, you would need to deal with this DEX somehow. So yeah, that's more or less it for the semantics. It's again, there's a lot of complexity in handling the classic entries, and an argument could be made to maybe limiting this CAP to only Sorban entries because this only appear in the footprints, and it is very simple check. So it seems like much simpler change than what is described here, but of course the impact is much more limited, and if an account gets corrupted for whatever reason, then of course we won't be able to do anything about it. Yeah, that's pretty much it for the semantics, and I guess I've touched this a little bit before, but yeah, and I want to emphasize that while this CAP may look controversial, validators already have censorship powers, and really what is proposed is basically an emergency mechanism that is also transparent, so it seems quite unlikely that it can be abused meaningfully. And you know, if validators conspire to do something bad anyways, then we probably will not learn about it, unlike this protocol mechanism that is at least observable. But yeah, I think the bigger downside to this CAP is really all the technical complexities this comes with, and the fact that we kind of do not know if this is ever going to be used. This is more like part of our response to potential things like to do if something like risk archival corruption bug happens again. But of course, we don't know what is the probability of that happening. So I guess it's kind of the main thing in an issue of this CAP. Yeah. Yeah, and to summarize the implications, it's really like you kind of access the entry, and depending on the number of contexts the entry can appear in, a number of operations will not be possible. So yeah, any questions or thoughts on why this is a good idea or bad idea, or we should do something else, are welcome. Right, second, all right. No one is coming. Right. Well, I will then stop here, and again, same for the other CAPs. Please feel free to comment on the discussion thread if you have any thoughts, questions, concerns, or anything. But I don't know. I think that's pretty much it for today's presentation. I guess while everyone is here, I just want to remind everyone about SLP4, which is a proposal to basically increase the limits for pretty much every resource in Sorbonne about 2 times, and also decrease non-refundable fees like 4 times, which means basically more stuff to do on chain for cheaper, which is cool. And please feel free to chime in the discussion if you have any thoughts on this as well. And yeah, that thanks everyone, and see you on the next protocol meeting.